Imagine an AI coding assistant that doesn't just give you a snippet, but constructs an entire complex application flawlessly on the very first attempt. Not by some magic incantation or, a lucky prompt, but through a profoundly different way of engaging with it. We're about to explore what could be a real paradigm shift for every developer out there. Welcome to the deep dive. Today, we're unpacking a fascinating evolution, really, in how developers work with AI, moving far beyond simple prompting into something much more structured and powerful: context engineering.
That's right. Yeah. If you've ever thrown a quick command at an AI and gotten back, well, absolute gibberish. This deep dive is specifically for you. We're going to really dig into a framework called the Product Requirements Prompt, or PRP. It's fundamentally changing the game.
Our mission today is to show you why those vague, hopeful prompts are quickly becoming, well, a relic of the past. We'll map out exactly how this PRP framework consistently delivers remarkably robust results, and how it transforms your role from just coding to truly becoming a code architect.
Exactly. And we're not just talking theory here. We'll walk you step by step through a concrete, real-world example, building something genuinely useful. So get ready to shift your thinking about how software gets made.
Okay, let's unpack this fundamental shift then. For a long time, the value of a developer was often measured by, the sheer volume of code they could produce, that whole 10x engineer myth, typing at warp speed. But our sources suggest that that way of thinking is, well, it seems it's officially over.
Yeah, what's truly fascinating here is how the very definition of the human role is changing. It really is. If an AI can now write incredibly high-quality, often bug-free code in just seconds, then our job isn't about the raw act of typing anymore. It's about providing the intelligent thinking that directs that AI.
So you're saying the AI becomes the ultimate hyper-efficient construction crew, capable of building anything you can imagine at astonishing speed. But they're not mind readers, right? They don't inherently know if you need a cutting-edge hospital or a luxury apartment complex, unless you give them a precise blueprint. That blueprint, that design, that vision that's now fundamentally our responsibility.
Precisely, yes. The code architect defines the overarching vision, meticulously designs the system architecture, provides truly comprehensive context, and then acts as the crucial quality control. It's less about memorizing syntax or optimizing some specific loop, and far more about high-level problem-solving and system design. Think of it less like being a camera operator and more like being the director of an entire feature film.
That's a significant reorientation, a big shift. So for developers listening, what's the most crucial mindset change they need to embrace to truly thrive in this new landscape?
It's focusing on architectural thinking, yeah. Not just the code writing itself. Now, let's talk about the hard truth, because, many people are still facing this. Most individuals attempting to use AI for coding are, frankly, still just vibing. That's the term used. They toss out a quick, often vague prompt, cross their fingers, and then spend hours, sometimes days, debugging the resulting mess. They might even optimistically call it prompt engineering.
Right. That's like trying to assemble something really complex, say the Death Star, by just shouting, make it big and round with a laser at a pile of scrap metal. It rarely ends well. You're almost guaranteed to get something. Well, something functionally challenging.
Exactly. And if we connect this to the bigger picture, the age-old garbage in, garbage out rule hasn't gone anywhere. If anything, it's amplified by the scale of AI. Context engineering is the intelligent, systematic superset of simple prompt engineering. It's about building a robust process, you see.
hmm You wouldn't give a human senior developer a 2-sentence Slack message and expect production-ready code. Of course not. You'd provide them with detailed documentation, clear requirements, maybe even existing code examples. So why would you treat a billion-dollar AI assistant, this incredibly powerful tool, like it can simply read your mind? You feed it garbage context, and you will get garbage code. It's really that simple.
So drilling down on that, what's the core reason why detailed context is so absolutely vital for AI coding success?
Fundamentally, AI needs comprehensive, engineered instructions to avoid bad results. So what does this all mean for practical day-to-day application? How do we actually do this? This is where the Product Requirements Prompt, or PRP, comes in. This powerful framework was originally developed by Rasmus Whiting, a product manager who became increasingly frustrated, frankly, with the often useless, inconsistent code he was getting back from AI. He knew there had to be a better way.
And the formula he cracked is quite brilliant in its simplicity and depth. It's PRP equals PRD,
Right.
which is your product requirements document, plus curated code-based intelligence, plus an agent runbook.
Okay, let's unpack that nerd speak a bit because each component is critical here. A PRD is essentially a crystal clear explanation of what you are building and, crucially, why. It defines the problem you're solving, the features, the user stories, all of that.
Right.
Curated code-based intelligence refers to providing the AI with examples of your good code, existing design patterns you follow, internal utility libraries, any relevant technical docs specific to your project or organization. It teaches the AI your way of building things.
Your style.
And finally, the Agent Runbook is a precise, step-by-step instruction manual for the AI, guiding its execution, including how to approach development, what specific tests to run, what criteria define success.
In essence, yeah, it's giving the AI absolutely everything it needs to generate production-ready code, often on the very first pass. No more endless back-and-forth debugging sessions, no more guessing games. It's not just prompting. It's truly engineering a miracle, almost, of software creation.
So what's the fundamental benefit you gain from meticulously using this PRP framework? What's the payoff?
It provides the AI everything needed for production-ready code. Fast. Very fast.
Okay.
And to truly demonstrate the power of this approach, we decided to tackle a real-world, non-trivial application, building an MCP server.
Okay, an MCP server, Model Context Protocol Server, that isn't just a simple web app, right? It's a tool that lets you dynamically extend your AI's capabilities with custom functions, allowing it to securely interact with specialized internal APIs or proprietary data sources that it wouldn't normally have access to. It's like giving your AI genuinely new superpowers tailored to your specific needs.
Exactly. And specifically, we built what we're calling a PRP Taskmaster, an AI tool designed to read a product requirements prompt and then automatically break it down into a highly detailed, actionable list of development tasks.
Yeah.
It's delightfully meta, isn't it? We use AI to build a tool that makes building with AI even easier.
And this particular example is perfect for showcasing context engineering because it possesses genuine, non-trivial complexity. It demands robust, production-ready code, complete with proper security considerations, meticulous error handling, a scalable architecture, and perhaps most importantly, it's genuinely useful for any developer grappling with complex AI projects.
So looking back, why did choosing this MCP server prove to be such an ideal demonstration for PRP?
Because it showcased complex, useful, production-ready AI development in action. All right, enough theory. We've laid out the philosophy and the core framework. That's the what and the why. Now, let's get concrete and walk through the actual step-by-step process of putting context engineering into practice. This is the 5-step blueprint. Step 1. Setting up your foundation. Before you even write a single prompt, you need a clear idea, obviously, of what you want to build. Access to a powerful AI assistant, and crucially, a well-structured context engineering template.
Right. These templates are incredibly powerful. They're like starting a complex video game with all the best cheat codes already enabled. That's a good analogy. More technically, they bootstrap the process with pre-built commands, established best practices, validated reference architectures, and often robust security configurations baked in from day one. They save countless hours and ensure consistency.
Okay, then step 2. The initial planning document, often called initial.MD. This is your comprehensive mission briefing for the AI. The more specific, detailed, and clear you are here, the better the output will be. For our PRP Taskmaster, we use this document to meticulously describe its purpose, its functionalities, its desired behaviors, everything.
Yeah, and a pro tip for this step, be relentlessly specific. Don't just say add user authentication. Detail how you want to implement it. Include references, like maybe a link to the Claude Taskmaster GitHub repository if you're building on an existing idea. That helps. Crucially, anticipate common AI gotchas, for instance. Explicitly call out how environment variables should be handled or what naming conventions to follow, and always frame features as well-defined user stories, detailing the who, what, and why from the end user's perspective. Step 3. Generated your PRP, the 15-minute research marathon. Okay, once your initial.md is complete, you hand this comprehensive blueprint over to the AI. A simple command like PRP create kicks off the entire process.
And this isn't an instant, trivial task for the AI, right? It takes time. During this phase, it diligently analyzes all your requirements, meticulously gathers relevant context from the intelligence you provided, then crafts a highly detailed, executable implementation plan. It even sets up internal validation gates and success criteria for itself.
Exactly. This really isn't an instant operation. It might take a solid 10 to 15 minutes for the AI to fully process everything. But while you're stepping away to grab a coffee or maybe brainstorming the next feature, the AI is performing the complex, high-level architectural work of a very senior software architect, quietly. Whoa, just think about that for a moment. Imagine scaling that across multiple projects or even within a huge enterprise. You could literally come back after a brief break to a fully implemented, thoroughly tested, and perfectly working application. It truly feels like magic, but it's engineered.
Then, step 4, the crucial validation step with everybody. Don't be that guy. This is absolutely critical. This is where professionals distinguish themselves. You absolutely cannot trust the AI blindly. You must rigorously review the product requirements prompt that the AI generates before proceeding.
Exactly. You're looking for logical architecture decisions, robust security implementations, comprehensive error handling strategies, adherence to your preferred code structure, all of it. Keep a sharp eye out for any weird details or potential security flaws, for example. We've seen instances where the AI might try to directly modify a secrets file. That's a huge vulnerability. Beep. And look, a vulnerable admission here. I still wrestle with prompt drift myself sometimes. It happens. Catching these small but critical errors in the generated plan is absolutely vital. It's easy to get complacent, you know.
And skipping this validation step is truly akin to a pilot taking off without performing a thorough pre-flight check. It might feel faster in the moment, but it could very easily turn into that "this is fine" meme moment, right before your entire security posture burns to the ground. That quick skip could cost you days or weeks of rework, or worse, a major breach. And finally, step 5. Execute the PRP watching code come to life. Once you've thoroughly reviewed and approved the AI-generated PRP, you simply run the execution command. And the AI doesn't just spit out a giant, undifferentiated blob of code. It's not what happens. Instead, it systematically creates a detailed to-do list, builds components methodically, runs predefined tests against them, and even intelligently self-corrects errors in real time as it goes.
Yeah, the numbers we saw for our PRP Taskmaster project were genuinely staggering, really impressive. From start to finish, the total execution time was a mere 25 minutes. Just 25 minutes. In that time, it built 18 fully functional tools, and it was production-ready on the very first shot. If you were to outsource this kind of specialized development, the estimated cost would easily exceed $5,000. Easily. That's an incredible return on, well, 15 minutes of AI work plus validation time.
Considering all these meticulously laid out steps, if you had to pinpoint one that separates the truly professional, the code architect, from those just vibing with prompts, what would it be and why?
The validation step definitely is most critical for ensuring quality and security. Mid-roll sponsor read. Okay, so even with a meticulously crafted PRP blueprint, there are still common traps, right? Pitfalls that can derail your efforts. Taking shortcuts can quickly turn a potential 25-minute project into a week-long nightmare. We've seen it happen.
Let's talk about trap #1. The vague brain dump. This is classic. This is where you might give the AI a prompt like, "Hey, I want a cool social media app for pet owners." Just that. What you'll likely get back is, well, a generic Instagram clone with maybe some dog pictures swapped in. The AI isn't a mind reader. It can only work with the specificity you provide.
Exactly. Your initial .md isn't a wish list. It's a precise briefing document, a spec. You have to be specific, almost to the point of obsession, detailing every user flow, every feature, every constraint. If you're not clear on what you want, how can an AI possibly build it correctly? Then there's trap #2, the trust fall execution. This happens when you get a beautifully generated PRP back from the AI. It looks great. And without a second thought, you immediately hit execute. You just assume it's perfect, flawless, exactly what you need.
And that's a dangerous assumption, a really dangerous one. Remember our earlier example. The AI, in its attempt to be helpful, might suggest writing directly to your secrets file or some other critical system component. That's a huge security vulnerability that could be catastrophic. You absolutely cannot perform a trust fall here. You need to verify.
Never, ever skip the validation step. You, the human developer, are the senior architect, the final checkpoint. That's your role now. The AI is a powerful tool, incredibly powerful, but it doesn't possess the judgment or the nuanced understanding of your system's security posture or business context that you do. That's crucial. And finally, trap #3, the context-free update. This one bites people later. You've got a working application, everything's humming along nicely, and then you casually ask the AI for, say, a new share to social media button. Seems simple, right?
Right, but the AI, lacking the full context of your existing code base, the design patterns, your current file structure, it might give you a hideous, functionally broken button that completely messes up your UI or breaks core functionality somewhere else. You'll then spend an hour or more fixing what should have been a 5-second fix. It's an efficiency trap. It wastes so much time.
Treat every update, even minor ones like a mini PRP. Provide comprehensive context every single time. Context engineering isn't a one-and-done task. It's an ongoing, disciplined approach to working with AI throughout the entire software lifecycle. It's a mindset.
So boiling it down, what's the single biggest risk inherent in falling for these common tempting traps?
It's wasted time, definitely broken code, and potentially serious security vulnerabilities.
So zooming in even further now, what does a truly perfect PRP, a robust product requirements prompt, actually look like structurally? It's far more than just a casual prompt. It's a comprehensive specification document that thoroughly guides the AI, as you said.
Absolutely. It starts with a very clear objective right up front, followed by detailed tool specifications defining what libraries, frameworks, or external APIs the AI should use. Then, you layer in crucial technical context and comprehensive reference documentation, links, examples, etc. But perhaps the most powerful part, as mentioned in the source, is the current versus desired structure. This gives the AI a crystal clear before and after picture of the codebase, detailing exactly how the architecture should evolve. It's like giving it coordinates.
Mm-hmm. And this level of detail is precisely why the PRP framework excels and consistently delivers. You front-load the intellectual heavy lifting, you do the deep thinking and the meticulous planning up front, and in return, you get a production-ready application, not just a messy proof of concept.
And there's one more critical piece to this puzzle we should mention: global rules.
Hmm.
These are core foundational principles that apply to every project, every piece of code you generate with this AI setup. And they typically live in a separate, easily accessible file that the AI always consults.
Right. As Rasmus Whiting, the creator of the PRP framework, wisely puts it, global rules are for things that will be true forever in your code base. PRPs are for the specific work you're doing right now. This ensures a level of consistency, maintainability, and adherence to your overarching engineering standards that would be incredibly difficult to achieve otherwise, especially at scale.
So thinking about that synergy, how do these global rules specifically enhance the effectiveness and the output quality of the PRP framework?
They ensure consistent, maintainable AI-generated code across all projects.
Okay, so this brings us to the big question, the one that's probably on many developers' minds right now.
Yeah.
This all sounds fantastic for brand new projects, starting fresh with a clean slate. But my current project's code base is, well, let's be honest, it's a tangled mess of spaghetti. Can this approach really work for me?
And the answer, according to our source material, is a resounding yes. It's not just for greenfield development.
Right. This is where that curated codebase intelligence section becomes even more vital. Critically important, actually. You systematically feed the AI examples of your existing code the good parts. Hopefully your internal design patterns, the unique way your files are structured, even common helper functions you use all the time. You're essentially teaching the AI your project's legacy, its DNA.
So the AI intelligently learns how you build things, your team's specific quirks, conventions, architectural decisions, and then it adapts its approach accordingly. It means it can add new features that seamlessly integrate and truly look and feel like you wrote them, rather than some generic, out-of-place AI code.
Yeah. This isn't about AI replacing developers. It's profoundly about giving existing developers incredible superpowers. That's the framing. It's shifting us away from the tedious, repetitive typing and debugging cycle and elevating us to high-level architectural thinking, strategic problem-solving, and quality assurance. That's the value add.
It's about moving faster, building better, and letting the AI truly handle the heavy, repetitive grunt work. Welcome, really, to the era of context engineering. We've taken a deep dive today into how context engineering, and specifically the product requirements prompt framework, is fundamentally transforming AI coding. It moves it from a, well, often hit or miss, frustrating experience to a high-precision, highly reliable one. And this redefines the developer's role to that of a true code architect, focusing on vision, comprehensive context, and strategic design rather than merely lines of code.
Absolutely. So if you're a developer listening or just someone deeply curious about the real-world impact and future of AI, we encourage you to reflect on how applying this kind of rigorous framework could dramatically change your entire workflow, your whole day even. It truly is like unlocking a new level of capability, gaining superpowers, as the source put it.
And consider this as a final thought. If AI can now reliably build complex, production-ready applications, provided we give it a truly comprehensive blueprint, what does this actually free up humanity, us, to really focus on? What new, even grander problems can we begin to solve when much of the heavy lifting of creation is so effectively handled? What comes next? Outro music.